Fine. So anything that reduces your effort. So let's say, for example, I talk about some topics like, and I have a frozen shoulder. So I'll talk about some topics. Let's say we talk about a thing called a jack. All of you know about a jack. What does a jack do? Okay, a jack lifts a car. Okay, a car, and a car is in the range of k, means kgs. So much is the mass, 1,000 kgs, right? Can you have the capacity to lift 1,000 kgs? You don't have the capacity to lift 1,000 kg, and it is lifted by a simple human being. Anywhere in a teenage, you will have your capacity to lift a car. Jack is a machine. So in this case, if I call this car as a load, okay, and if you look what you are applying, if I say that this is an effort, so a machine is something, in this case, what it is doing, if I see my load divided by effort, okay, if I just see this ratio, my effort is always less, right? The load is much more than my effort. So this ratio goes more than 1. Have you seen this? Are you able to understand? The load is much more, the effort is much less. The car lifts. So the machine, in such a case, a jack is known as a force multiplier. You have to understand how do you classify a machine. The first type of classification is force multiplier, where we will apply a small force and the force will get multiplied and you will be able to lift a much more higher mass object through it. You just can't lift a car with your hand, but through a jack you can do it. So does a jack qualify as a machine? Yes, a jack qualifies as a machine. And the first property that we got to know about a machine is that a machine is a force multiplier. Is this understood? Okay. Let's see one more instance. Okay. Let's see one more instance. And that's something like this. Say, fine. 1 minute. पुली सोच रहे हो, पुली नहीं है ये, देखते हैं ना क्या आता है. Right. The way they have introduced the topic, you will neither understand anything nor will you develop any interest. At least I feel so. Right. A bicycle wheel. This is the rear wheel of your bicycle, right? The rear wheel of your bicycle actually rotates as you are driving, right? You are turning this rear wheel of bicycle. So if you see the rear wheel of bicycle, the rear wheel of bicycle actually has a gear hub out here, right? And it has another sprocket out here also, right? There is another sprocket out here. And what we are doing in this case is that we are using what is known as a chain drive. We're using a chain drive to actually pedal our bicycle. Okay? We use a chain drive. So this is our chain drive. Chain drive. Imagine sitting yourself on your seat. Can you pedal your bicycle wheel? Your bicycle wheel is quite behind you. Can you pedal the bicycle wheel? Probably not, right? But if you change the bicycle wheels, the pedal out here in this orientation, what happens is that your pedaling becomes easy. Your pedaling becomes much more easy. This is also a machine. Here we say that by shifting the point of application of effort. Just see, in the first instance we saw what did we see? We saw a jack. What does a jack do? A jack works as a force multiplier. It is such a machine that no matter how much force I give, it multiplies my force, that is my effort, and is capable to lift the load. Here the load is here. I am supposed to apply my effort at this place. But here the machine is working as a convenience for me. I have shifted. Every time machine may not be a force multiplier. Machine is anything which makes you do your 3 idiot definition. हर वो चीज जो आपके काम को आसान करे, makes it easy. You have shifted the point of effort from the sprocket of the wheel to a chain drive, through a chain drive, little bit ahead. This is also a machine. So 1 point, what did we see? Force multiplier. What did you see here? A machine is also a device which can move the point of application of effort to a convenient point and thus make the operation easier. What is the operation? To rotate. Clear? Let's see one more. Okay, let's see one more. Okay, one more diagram. Let's say you have you might be having something like, say I have a load and I have to lift this load. You want to lift this load, right? Now if you lift this load right from the bottom, then you bend down and you're picking up this load. It's just like say a bucket from the well. You're trying to pick it up in this manner. Even in this case also, शायद आपका तकलीफ ज़्यादा होगा. You'll have more, more effort will be needed by you. So let's see whether we can make our job a little bit easier. Okay, let's see whether we can make our job easier. So what we do, here we bring the concept of what is known as a, say, a pulley. Right? Fine. So out here what we are doing, this is our string. The string is tied to the load. It's tied to my load. Okay. And here I'll have the other end of the string. Other end of string. And let's say that you have a person out here who is actually pulling it. This is a pulley. So if you see a force diagram of a pulley, though we will be studying the pulley more in detail, if you around the pulley, yeah, we do. So that is not shown. It is understood that it is going around. No, it's just going one round around it. Will you understand the pulley? Here, don't try to break your head on the pulley. So let's just see a little bit of some force diagrams. Okay, so you have a load out here. This is the load. The load which is hanging down. The load is held right now because there is an equal amount of tension on the spring also. Obviously, there is a tension on the spring. The tension is balancing the load. If the load increases the tension, the rope will snap and the load will drang se gir jayega, right? And also, what I should also draw, you will think that the pulley is floating in the air, and it's not like that. So the pulley is also actually fixed to a frame. And when you fix a pulley to a frame, obviously we will have an axle through which the pulley is rotating and a nail will be put inside this. Okay, safety nail will be there. And let's say this is the pulley bar. Right, now see. Now the load is acting on the downward direction. The tension is actually working on the upward. Tension, whenever you want to calculate, wherever you want to calculate, just sit at that place and open an umbrella. As I told you, sit here and open the umbrella. Where will you open? Upwards. So that's the tension. Similarly, you are applying an effort E out here. Do you agree or not? That is with which you are pulling. And your effort E also has to balance the tension in the string. Right? Otherwise, string toot jana chahiye na? So if you see a pulley, in pulley, the load is also equal to the tension. The effort is also equal to the tension. That means a pulley does not, and if you see the ratio of L upon E, the ratio of L upon E is exactly equal to 1. A pulley is not a force multiplier. Pulley is not a force multiplier. If this combination is not a force multiplier, if this is 500 newtons, you will need 500 newtons of effort worth in you to lift it. A pulley is only changing the direction of the effort which you are applying. It is much difficult to pull up 500 newtons this way, but it is easy to pull up 500 newtons in this manner. Have you understood? So here what we are doing, here we are changing the direction of effort. Direction of effort. Please mind that there is no sense of any force multiplication out here. A jack is a force multiplier. If you use a pulley does not make your job easy in terms of effort. A pulley makes your job comfortable in terms of the direction of the effort that you are doing. Imagine yourself in a village well, you would be otherwise pulling up the bucket of water by bending downwards. Now you are pulling up the bucket of water in this manner. So that's your
And the wheel, both of them are the same.
No, wheel is where you are, the point of application of effort has been shifted to a different place.
Yeah.
This is changing the direction of effort. Changing the direction of effort. What did you actually, how do you say changing the direction of effort? How do you want the load to be moved? You tell me, how do you want the load to be moved? No, load will be moving vertically upwards. What is your end result? The water to come up. Jack faced a pail of water. You want the load to come up. So you are not giving the effort in the same direction. So if you look at a jack is also giving the effort in the same direction. This is not giving in the same direction. It's giving the effort in the opposite direction. However, the load is, both are different. Three things we studied. One was force multiplier. What is a force multiplier? A sort of machine in which the effort is much, much less as compared to the load that you want to overcome. Where your physical, strength is limited and you want to lift something more heavy, then what comes up? A force multiplier comes up. Then we saw where something is made convenient for you. Something is made convenient for you. That convenient part is actually in a bicycle. So where the point of application of effort is shifted. Let's look at this type of machine. Yeah, previous one. क्या diagram बनाने के लिए बैठे हो? By shifting the point of effort, point of application of effort. We'll write all those things, don't worry. We'll write again. By shifting the point of application of effort. हाँ, बना ले भाई. मैं चाहता हूँ आप मजा लो. आपकी बुक में ये सब नहीं रहेगा. आप इंटरेस्ट लो इसमें. Diagram important. पहले आप समझो. Have you understood so that you can draw that? Give it as an example to somebody else. What is a machine? A machine is something which can be a force multiplier. A machine is something by which we are able to shift the point of application of effort to our comfort. A machine is something in which we can change the direction of effort to give us comfort. Second one is also the third one is also a comfort point. We have actually shifted. हाँ, हो गया? कौन सा? ये ठीक है, चले आगे. चलो अब एक फोर्थ वाला देखते हैं. नंबर 4 सीजर्स को देखते हैं थोड़ा सा. राइट एंड सॉरी उल्टा हो गया ना. Sorry. Sorry. My mistake. 1 minute. Right. Now look at the scissors. आप वो छोड़ दो. आप scissors के चीज को समझो पहले. In scissors just see. If you look at the effort side, right? For scissors is a different class of machine. Here, if you see the movement on the effort side, the effort side movement is smaller, the load side movement is much bigger. Small movements on this side is actually making you do larger movement on the other side. Do you understand? Such sort of machines are called in which you get what is called a gain in speed. Gain in speed. क्या गड़बड़ हुआ है इसमें बोलो? Gain in speed means, we will see what is gain in speed. This one moves faster. This one moves slower. But this one will do much more job than this one. See, every time you cannot be only a force multiplier. Sometimes we need gain in speed. If you see the the velocity of the effort, how does a scissor move? This side, your fingers will be moving much more faster. This one will be moving slower. But as a result, you will find gain. When we say gain in speed, means we see, look at the velocity of the effort side. Effort side velocity is more. And if you look at the velocity of the load side, the load side's velocity is less. We are not interested in the velocity, but we are more interested. What is a scissor used for? Snipping. Yeah, you see that it will snip.
तो speed वाला नहीं समझता है दोनों
How fast are you moving your fingers? That will not move that fast.
टीवी तो move करेगा because
That will do the job of a bigger cut.
हाँ move also with the speed.
Nahi, it doesn't go that way. Here, the what we say is the velocity of the effort. The velocity of the effort will be more. Velocity of the load will be less. So a machine can be something. In that case, we say that the machine is obtaining what is known as a gain in speed. Have you understood? 4 things we can get by a machine. A machine can be a force multiplier. A machine can change the point of application of effort. A machine can change the direction of effort. A machine can also result in gain in speed. In doing all these 4, or combination of 1, 2, or a combination of only 1, you will be able to overcome a much more resistive force, which is called the load, by the application of an effort. So we are now ready to define. So if you define a machine, how do you define? You say a machine is a device, right? Anything that makes your job easy. But how do we say? A machine is a device. Just socho, pehle socho. Machine is a device by which we are able to overcome a much more resistive force. What is that called? Load. By the application of a smaller force, effort, either by a force multiplier, or by changing the point of application of the effort, or by changing the direction of effort, or through a gain in speed. You cannot have gain in speed and force multiplier at the same time. एक ही साथ दोनों नहीं होगा. One who is a force multiplier, he will not be a gain in speed. You will see that. A machine which is a force multiplier cannot be a gain in speed. वो नहीं हो सकता है. We will see that mathematically. अगर आपका mechanical, a machine who has more what you call force multiplier, he cannot result in a gain in speed. At the end of the day, your job may take more time, but your job has to be easy. Machine is not supposed to do every time job in less amount of time. Suppose you are cutting a big sheet of plate. You can't cut that big sheet of plate with your hands immediately when it's on spot on job. But however, if you have the snips, आपने देखा है बड़े-बड़े snips होते हैं, sheet cutter snips. Can you shear up a sheet of plate? No, you can't. Take your steel ki thali in which you are having food. There are snips available with which if you just cut, touch, it starts cutting that entire plate. Yeah. Steel. That one, can that cut 2 layers of my denim? No. A much more heavier, what do we call that? Shears. A much more heavier shear will cut denim. There are shears available to cut carpet also. But can you shear a carpet in this manner? No. So it makes your job easier. It's not about time always. It's not always about time. Okay? So a machine is any device. A machine is any device in which we are able to overcome. If we just see in point wise. So we have a machine. A machine helps us overcome what? A large resistive force. And what is this large resistive force called? Load. Right? By the application, by applying a comparatively less force.
A large resistive force.
Resistive force. The resistive force is, the load is a resistive force. No, it doesn't want to go. You're asking it, you're trying to move it. Is ziddi hai. By applying a comparatively less force, which is called your effort, either as a force multiplier Number one. Number two, or by changing the, you can yourself write now, point of application of effort, or and, both can be there. Changing the direction of effort, or by a gain in speed. Either ways. This is a machine. So we saw a jack, we saw a bicycle pedal, we saw a pulley. There are many other things. We have seen screw. We have not seen. We have a screw. We have wedge. We have inclined plane. In everywhere, your idea should be how your effort can be reduced. If you are giving more effort than the load, then you have designed a wrong sort of a machine. Okay? We need to understand some more terms as we get into this. Let's understand some terms. Load. Load is the force, that is the resistive you want to overcome. I hope by now you know what is a load. Your headache is the load. What you want to do, your job's headache is your load. Effort. The effort will be known as force applied. We will call this as E, and the load will be called as L. Then we study something called mechanical advantage. Now this is important in your course. This is important. Mechanical advantage. Mechanical advantage is denoted as MA. It is an advantage. It is the ratio of load over effort. It is the ratio of load over effort. So MA can be greater than 1. In this case, what are you? You are a force multiplier. U means the machine is a force multiplier. कहाँ पे लिखा ना? Can be used either as a force multiplier. कहानी पढ़ो, मैंने नहीं लिखा, भी आप लिखो ना. I'm good. You have understood. That means that's what I want. If the see what is happening now, since you two are so busy writing, you are missing this interesting discussion. In the class of science and physics, you will not be able to run with the teacher or professor or whoever it is as you are going up. If you go to higher colleges, they will use 3 boards. Have you seen 2-3 boards wala classes? This one will be pulled up, the second one will be. Aap kitna likhoge? You should sit with rapt attention and a scribble pad and start noting down what sir is saying. Is the class getting videographed? Yes. Pay your attention at that time. अगर आप इसको लिखोगे ना, right now you have come empty mind. Your job is to keep on absorbing as things are being said. You cannot match my pace because you don't know. Are you writing? No, I am writing. I am in my control of mind. How can you write? You listen. You understand. So we need to understand what some terms. Load. Load is what you are trying to overcome. Your headache of the job. Effort is what is in your control. What you can apply. Then we understand something called mechanical advantage. What is your advantage? Advantage is load upon effort. Have you understood? This ratio can be greater than 1. If the ratio is greater than 1 means what? Greater than 1 means load is more, effort is less. To make it greater than 1 means trying to lift 10 kg by applying 2 kg. So the machine is advantageous to me. So it will be known as a force multiplier. If your MA is equal to 1, then your machine will only do change in direction of effort. Soch ke dekho, pulley. In the case of pulley, the load and the effort is same. If I need to lift 40 kg through a pulley, 40 kg means 40 into 10, 400 newtons. You also have to apply 400 newtons. You do not have any discount like a jack. In that case, the mechanical advantage will be equal to 1. That does not mean it is not a machine. It is still a machine because it is giving me comfort. ma equal to 1 means no force multiplication. It will only be change in direction of effort. There can be machine where ma is less than 1 also. Then this machine will result in gain in speed. Therefore, we say force multiplication and gain in speed cannot happen together. More than one.
Not equal to 1.
Equal to, not equal to means these two categories. That's what your brain is working now. See, you are asking and you are yourself contradicting. That means you are thinking. वो लिखते रहने से आपका thinking नहीं आ रहा है. Then you will never see what will happen after grade 10. You have to choose either humanities or science. Even if you move with humanities, love the subject and move. If you're moving with science, love the subject and move. Don't move because you have to study. I'll tell you honestly, I had maths was never my very first subject that I used to love on the first go. I used to love chemistry much more and physics much more. I did not move to grade 11 just because I had to study that. Yes, I felt sad when I had to forego Hindi because in our times, Hindi was not allowed in science section. That was my sad part. History I had to leave. That was my sad part. But I wanted this. मैं इसको पसंद करके गया. मैं नहीं चाहता हूं कि आप जबरदस्ती इसको जाए. लेकिन you like it or not depends upon at least you have to eat it once. Then say I don't like. आप नहीं खा के, the way you all are studying, you will never develop the choice. That's what I'm saying. Mechanical advantage greater than 1. Is this clear? Right. Then we talk about something called efficiency. Efficiency. Yeah. Efficiency is anywhere will always be output energy divided by input energy, right? So it will be output work divided by input work. So let us see like this. Efficiency is output energy divided by input energy. We can also write it as output work divided by input work because as per work energy theorem, energy and work are same. Do you agree? हाँ और लिखते हैं ना, मुझे मुश्किल क्या है अभी तो और जैसे. Now output work can be written as how? Output is always on the load side. So we'll say the load work divided by the effort work. Is this clear? Load work divided by effort work. What is load work? Load multiplied by distance moved by load. Work is force into displacement. What is effort work? Effort multiplied by distance moved by effort. Let's keep it right there right now. As of now, let it be there. ठीक है? चार वे में देखा. Efficiency always means what is your output divided by input. Output work by input work. Load work by effort work. Load into load's distance. Load means the car. How much did the car move? How much did the jack arm move? Right? अच्छा, अब इसको एक और चीज में देखो. Efficiency can never be equal to 100%. It can never be equal to 100% because every machine will have some frictional losses, and the frictional loss overcome is the biggest loss actually, right? So if the efficiency is not, if efficiency is equal to 100%, I will call that machine as an ideal machine. Ideal machine. So if you see the condition of my what do you call pulley, in my pulley, the amount of load you were giving was equal to effort. And in a pulley, you will see the load climbs 3 feet, you also pull the string 3 feet. So in a pulley, the efficiency is how much? 100%. Those are called ideal pulley. We do those we consider those pulleys in mechanical engineering consideration and while doing numericals. But in the real world, no pulley can be 100% efficient. There will always be, when the pulley is rotating on an axle, so it will make some cheek noises. So there is some friction there also, right? 100% हो सकता है, but 100% हो ही नहीं सकता है. Theoretically हो सकता है. So if it is theoretically, because theoretically we feel ना जितना load है उतना ही effort है. And in a pulley, the bucket will rise 2 centimeter, you will be pulling 2 centimeter this side, right? Now we see one more thing which is not there in your book, but without that you should not study what is known as machines. Velocity ratio. One was mechanical advantage and one is called velocity ratio. Velocity ratio is the velocity of the effort over the velocity of load. Velocity of the effort depends on type of machine. If the effort is moving, at what speed the effort is moving. Correct? Let us now try to deduce this thing. You know, speed into time gives you what? Distance. Let's say we freeze the time is t. In this t time, I gave an effort, so the effort has moved. The load will also move in that t time only. I am applying a force of say 5 Newton for 2 seconds. I expect some movement in the load. The load, that movement will also happen in t seconds only. So let us say, let's put it right now. Now, if I say the velocity of the effort multiplied by the time gives you the distance moved by the effort. Clear as per this diagram? Or sorry, this equation, is it clear? Similarly, the velocity of the load into the time will give you the distance moved by the load. Obviously, if the load's velocity is less, obviously the distance moved will be less. Understood? So from here, if I look at this ratio VE by VL, can I not write it as DE by DL, where T and T gets cancelled with each other? Right? Now come back here. Efficiency is load upon effort multiplied by DL by DE. Do you agree? And I am now writing it as efficiency is denoted by the Greek letter eta. So this is eta. L upon E multiplied by 1 upon DE by DL. Can I not write this? Easy. From here, can I not write efficiency is equal to mechanical advantage divided by velocity ratio? This is velocity ratio, no? DE by DL. Is this not velocity ratio? This is what you have written, velocity ratio, which is equal to DE by DL. ये आपके बुक में नहीं है, लेकिन आपका साथ जो ICC वाला पढ़ के आ रहे हैं वो है. So we get our equation. Mechanical advantage is always efficiency multiplied by velocity ratio. Do you understand? So the mechanical advantage of a machine, if it is, say the machine's mechanical advantage is 1, right? 1, the machine cannot be ideal. And if you want to multiply and relate it on this side, then this side it should be, if this is 1, then this is also equal to 1. Both cannot be in a manner in which both will be increasing at the same time. Abhi aap dekh lo na. If you make this as 3, this cannot be 3. It's not possible. So a machine whose mechanical advantage is more than 1, that is a force multiplier, will not be high in the terms of velocity ratio. Velocity ratio in your syllabus is not covered. I just brought it to make you understand that how efficiency, even efficiency they are not covering. Efficiency is output by input, load upon effort, load by this. Did you understand this? This is an equation that we use in mechanics a lot. A machine's mechanical advantage is given by the efficiency multiplied by velocity ratio. Acha, where will the, now a question comes. Suppose, sir, efficiency is equal to 1. What type of machine? Ideal machine. Mechanical advantage should be equal to velocity ratio. Exactly, it proves in the case of a pulley. In the case of a pulley, mechanical advantage is what? Say 1. Load upon E is 1. VR is also 1. Distance moved by the load is the distance moved by the effort. But is that really possible? No, that's not really possible. Therefore, this is never equal to this. This will be always some point. So we say, let's say efficiency is equal to 80%. Have you understood? 80%. That means the value of efficiency is to be taken as 0.80. So the mechanical advantage will be 0.8 times the velocity ratio. Only in an ideal machine, the mechanical advantage will be 1 times the velocity ratio. Means mechanical advantage is equal to velocity ratio. Go back to your previous one. Now let's see the pulley once again. Look here. Whatever is the load is equal to the effort. The load and effort are same. Therefore, mechanical advantage is 1. If it moves 20 centimeter, this also moves 20 centimeter. Velocity ratio is also 1. 1 equal to 1. That means efficiency is also equal to 1. That's an ideal pulley. Is the basic introduction of machines clear with you? Machine, any item which can either be a force multiplier or which can help you to change the point of application of effort, or which can change the direction of application of effort, or which can cause a gain in speed. All these are known as machines. And to understand machines, some terms we should know. These terms are, we should know what is a load, we should know what is an effort, we should know what is a mechanical advantage. This is there in your syllabus, load upon effort, always remember. And we should know what is efficiency. This part is not covered in your syllabus, but still I covered it. Efficiency is always given by output by input. Any machine's efficiency is output by input. And mechanical advantage is eta times the velocity ratio. Velocity ratio is velocity of effort over velocity of load, which becomes dE by dl, not in your syllabus, but again I'm saying. Right. So your syllabus studies 3 types of machines: inclined plane, pulley, and levers. So let us see the pulley first. Okay, the pulley is the most interesting one. Deck tank pulley ko. Right. So let's see the construction of a pulley. So a pulley will typically have a bar on which the pulley is actually, the entire setup is mounted upon. So this is the bar on which the is mounted upon, and the pulley will have a central frame. Okay, this we call this as a central frame. So there will be a central frame, fine, and from here, say suppose there is a S hook on which the central frame is hanging. Then you will have the disc, the pulley disc. So your pulley disc is something like this, right? And this is your pulley's disc. And this pulley, you are seeing it from one side, beta. Okay. So this frame is in this manner. The pulley, there will be 2 frames actually. The pulley will be in between, and we will put one axle through it, one bolt sort of thing on which the pulley has to rotate. Getting it? So that axle is this one. This is the axle of the pulley. Have you understood? So these are my 2 frames. Between the frame, the disc is there, and then you have put a rod inside it, which is the axle on which. Now, since you have put the rod, entire thing should not come out. So we'll put one clip on this side and one clip on this side. So those clips are like nails. We call them nails. So the nails will be somewhat like this. I can show it to you only from one direction. Oh, the nails will be like this. Yeah, it's a nail. So like this, a nail will be put up. Nail. Right? If you look at this pulley from the side view, if I look this pulley, now this is the pulley, the circle. I'm trying to look it from this side. Then my pulley will be typically, let's say, from here. So let's take some center lines, okay? All drawings are always to be done with center lines. Then your drawing will be perfect. So this is one center line. This is the other. And this is the other. Now you're trying to look at the pulley from this side. You're trying to look at the pulley from this side. How do you see the pulley? You'll see it in this manner. This is the width of the pulley. And right at the middle of the pulley is actually grooved. Did you understand what does this mean? This portion is no more there actually. This bottom one and this one, they're not there. The pulley is grooved. Have you seen your kada dekho chudi? The chudi is elevated on the upper side. Take the elevation on the inside. The rope has to dance on it, na? Okay, let me draw it once again. Let me draw it once again. So it will be something like this. 1 minute, 1 minute. Like a yo-yo. Exactly. Yeah, बेटा वो सब पूछा मत करो. This is how your pulley is from the side.
Oh, okay, yeah.
Are you getting it? From the disc side is like this. There's a groove here. On that groove.
See, you see those two numbers, right? That's the side. Yeah.
There will be a groove. On that groove, the rope will be other. The rope will come out, ना? हाँ, थोड़ा ऐसे अंदर की तरफ ऐसा है. हाँ, ऐसा है. Typically ये ऐसा है. ये groove है. इसके हाँ, इसके अंदर से. So the rope is actually और तुम लोग ये पुली भी नहीं देखे हो यार, और फिर भी क्लास में क्या अच्छा हुआ इसने मुझे ये बताया. This is how the pulley works. This is the rope. So in this manner. Yeah. Got it? Now, in all calculations purpose, children, the rope that we use, the rope is always said to be a massless rope. Because we always do our studies with the ideal pulley, the rope is said to be massless. Even in grade 11 also mechanics problem if you do, the rope is said to be massless and does not have any friction. It slides over it. So there is no friction. No, friction means not the rope's friction. There is no friction at the axle. It's an ideal pulley. So this will be my rope. And for all calculations, unless very high-end problem, the rope is taken as massless. And no friction, no frictional losses. That means this is my ideal pulley. Not ideal, huh? Ideal pulley. Yeah. And if you look at the rope now, the rope is actually hanging on this portion. The rope actually winds on this side. This is where the rope goes. Okay? So a pulley will have, this will be known as my frame. This is known as my axle, the white one. The yellow one will be known as my nail. This is my disc. That's it. And this is my support. And this is my hook. The hook on which the pulley is there. So the job of the pulley is to lift a load. We call this as load. And this is lifted by so this side will be the tension, this side will be the effort, this is the tension, and on this side we will have what is known as the load. This is called a simple pulley. This is simple pulley. Simple pulley. So if you see a simple pulley, let's go by our mechanical advantage. So in a simple pulley, load is equal to tension, effort is equal to tension, which tells that load is equal to effort, right? So the mechanical advantage of a simple pulley is load over effort, which is equal to 1. That means a pulley is neither a force multiplier, nor does it help in any sort of gain in speed. A pulley just changes the direction of force. So it's only a change in. देखा, तभी तुम लोग नोट करने के लिए बिजी थे, अभी सीरियसली पढ़ रहे हैं डायरेक्शन ऑफ एफर्ट. ठीक है, वैसा पढ़ा था तो तेरे सिलेबस कब खत्म हो जाता. सेकेंड, Let's look at the velocity ratio. Okay. Now just see this once with me. Velocity ratio is what? Distance moved by effort over distance moved by load. dE over dL. Though velocity ratio is not in CBSE. Now look, if the effort comes 10 centimeters down, this also has to go 10 centimeters up. So in this case, this is also equal to 1 as dE is equal to dL. So in a simple pulley, and if the simple pulley is an ideal pulley, you don't even have any gain in speed. So why do I still classify it as a machine? I still classify it as a machine because it helps me reduce my effort by in terms of the direction in which I am applying effort. Okay? But this simple pulley, if made as a movable pulley, can actually work wonders. देखो अभी अगला ये सिंपल पुली है, इसमें तो कोई लाभ नहीं मिला, ताकत उतना ही लग रहा है. Do you agree or not? But in every workshop, we don't have cranes, cannot go inside shed areas. So if you go to big workshops, you'll always see chain blocks out there. In Bollywood movies and all, you'll see that same chain will be pulled up. There will be S hook like that. So chain blocks will be there and chain pulley and chain blocks work wonders. Even you can lift the entire truck chassis. We'll see that how that is done. Okay? This is simple pulley. So let's see. This does not help it. It's not a force multiplier. But how can a pulley be made as a force multiplier? Pulley can also be made as a force multiplier, in which we call that system as a movable pulley. एक बार देख लो, उसके बाद सब कर. Movable pulley. So let's see a movable pulley. Right. देखो. So let's say right, and let us have the frame of this pulley now in the downward direction. This is the frame of the pulley. Okay? In the downward direction. This is what is mechanics all about, na? And you have a S hook, and on S hook means समझ में आया ना? The ones which you have on necklaces and other thing, the same thing. S hook, and this is your load. Okay? This is your load. Now this pulley is a. अच्छा, what was a simple pulley? Simple pulley is also known as this. इसको हमने क्या पढ़ा था? Simple pulley. Simple pulley का एक और नाम होता है fixed pulley. Fixed pulley. What is the difference between this? The axle is always fixed. Axle cannot do any movement. Whereas in the next type of pulley that we are having, the axle of the pulley will undergo movement. अब जरा देखो तो क्या interesting चीज होता है. Just see what interesting thing happens. ठीक है? Now let's take our string and let our string be attached here. Okay? And let the other string go in this manner. Have you understood? Now this pulley is a movable pulley. That means, let us see the force diagrams. So this is my load. This is my load, and this is how much? This is tension. And if you apply the effort on this side, you are applying the effort. This particular thing is on a rail. In this rail, this pulley can actually move. Have you understood? We have a sort of a. No. This is elevators and all. We have a. Yeah. Okay, we say have a rail. There's a rail, and on this rail, this pulley is sliding up and sliding down. Okay, now let's see how this will help us. Now what I'm doing, I still know that I have a concept of something called a fixed pulley. A fixed pulley is one which will actually reduce my effort, not reduce my effort, change the direction of effort. Okay. So I take another fixed pulley. right? And say that this is a fixed pulley. So this is my, there is a S hook out here. This is a fixed pulley, okay? आप लोगों अभी भी you didn't actually understand, otherwise you would have enjoyed. You still didn't understand what is the advantage of using this sort of a pulley. Now see this. This is called movable pulley. Are you able to understand the mechanism first? The fellow could have pulled it here also. This will be a mechanical advantage pulley, because here the load is shared across both the tensions. No. Earlier, if in this case the tension and load were actually on the same, tension was equal to load. But if you see this load, this is equally divided on. So there's a tension on this side also, right? Tension. And you are giving effort on this side, and your effort is also equal to tension. Mechanics ko samjho. This one I introduced just to make my job easy. Otherwise, this one itself, without this also, this is a force multiplier. Why? You would have lifted it with hand. The pulley would have come up with hand. The biggest advantage is the load is distributed on two strings. Just see the mechanical calculation. The load is equal to 2T. Do you agree? T plus T is balancing the load. Yes or no? Whereas the effort is equal to the tension. Now see the mechanical advantage. L over E, which is equal to 2T by T, which is 2. With half the amount of force, if this is 500 kg, you apply 250 kg. And you will be able to lift it. But my next question, why do you stop here only? You make this also movable. Have you understood? Make the first pulley be right at the bottom. It climbs and is being pulled up by another pulley which will also be movable. Third pulley also movable. Fourth pulley also movable. Fifth one will just change the direction. So how many number of times you have reduced? If you take 10 pulleys, you will need 1/10 the effort. 2 pulley में half कर दिया. 5 pulley लेंगे तो 1/5 हो जाएगा. That is called a block and tackle system, which is there in industries. You will have many pulleys, pulley 1, pulley 2, pulley 3, pulley 4, pulley 5, pulley 6. If you pull the first one, second one will pull this one a little bit up, this will pull up, this will pull up, this will pull up. Ultimately, your little effort is compounded over all the pulleys. Did you understand this? This is known as a movable pulley. All industries, no, not theaters. The first thing is every car. That's the problem. Now you all don't watch. How does an assembly of a car bench happen? Suppose you are on a Suzuki bench. You have to bring that engine block. How is the engine block coming? Through pulley system. And precisely it has to be fitted. We'll put some pneumatic controls so that ye jhatke mein nahi girega, and exactly bolt to bolt match it has to fall. The block of a truck engine is so heavy. How are they matching it? Ab haath se thodi bithaoge. When you open a small ceiling fan or something, you can match the bolt hole to bolt hole in this manner. Such heavy things, how will you set? That's why I say, when your car goes for servicing, go with it and ask the workshop manager, can I see inside? How is a heavy car engine completely dismounted? Do we lift it? Crane cannot go inside. A crane is a very bulky thing. By the time the crane goes inside, it will scratch 5-6 cars. So any industry will have something called hard hat zone. Hard hat zone means hoist movement is happening. You're not to be without your helmet. That's a hard hat zone. Means crane movement is happening. So when you enter any sort of a industry shed, like say a Decathlon or something, if Decathlon is a work shed, then on this side you will see one yellow big pyre. On this side one yellow big pyre. And on that side one yellow. On those two things, the entire rails are running. Suddenly they will make a horn. Teent, 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 heavy object is moving. You have to be very careful. Industry working aise nahi hota hai. Hard hat zone. If somebody is working with a spanner on top, the spanner can fall. And if it falls on your head, Kiss yourself goodbye. So the crane will be moving. This is, did you understand this thing? So here, if you see, the mechanical advantage of this is become. Let's see also the velocity ratio. So if you see the velocity ratio here, if you see the velocity ratio, okay, though that is not covered in your syllabus, distance moved by effort over distance moved by load. Now this is interesting. If the load moves 5 centimeters, each of them will move 2.5 and 2.5. हाँ, क्योंकि अभी एक बार में नहीं उठ रहा है ना, दोनों साइड उठ रहा है, दोनों साइड उठ रहा है, right? So we can say if the distance moved by the effort is something like say 2, right? The distance moved by the load will be 4. So here it becomes half. So if you are a force multiplier, you won't have gain in speed. Please understand. Because, and here also, if you start pulling it, immediately this will not come up. Because every time you pull 8 centimeters, the load will climb 4 centimeters only. But I am talking of system where we will have compound pulleys, 5 pulleys out here. So every time you move 10, load will move only 2. धीरे धीरे. तो इसमें स्पीड गेन नहीं होगा, पर मैकेनिकल एडवांटेज ह्यूज आ जाएगा. If you have 5 pulley systems with 1/5 of the effort, you will be able to pull your load. एक प्रॉब्लम करें पुली के ऊपर. वेरी इजी क्वेश्चन एक लेके आया था मैं फ्रॉम ICSE. आओ देखते हैं, हमारे पास तो होता नहीं है ना. आओ. Okay, so let's see one example. I had sent it to my wife's mobile. कहाँ गया? किसी और को भेज दिया क्या? या अब वो बाद में कॉपी करता हूँ ना. एक प्रॉब्लम को देख लेते हैं फिर. सिंपल. So I'm making a usual drawing. Okay, just a normal drawing. So we have a pulley. Okay, and this is my frame. And I have got a pulley, and the pulley is connected to 400 newtons, and this side we have our friend Rishika. She is applying 480 newtons. This is a classic. This is a real life case. In real life, your load cannot be equal to effort because there will be losses. तो इसको मेहनत तो ज़्यादा करना है, ठीक है? This is the question, and in this question, it said that the height with which you will lift the load will be 5 meters. To do that job, you will take 10 seconds. All right, and blah blah. So have you understood the question? Quick, we have already crossed time. So we have a pulley in which we will be lifting a load of 400 newtons by applying an effort of how much beta? 480. You should ask me, sir, why is the mismatch? Because there will be frictional losses, right? That means this pulley is not 100% efficient. Right. The first question: what is the velocity ratio of the pulley? What is the velocity ratio of the pulley? So what is velocity ratio? Velocity ratio will be distance moved by effort over distance moved by load. But still we don't know. You are not given any distance moved by effort and distance. Okay. What is the mechanical advantage? So let's tell. What is the mechanical advantage? L over E, which is equal to 400 divided by 480, right? So 410 and 4 1 12, right? So 2 5s are 10, 5 by 6. So 5 by 6 is your mechanical advantage. Okay, obviously you are getting it less than 1 because you are giving more thing, right? Okay, now it says calculate the efficiency of the pulley. Now in order to calculate the efficiency of the pulley, efficiency multiplied by velocity ratio will give you your mechanical advantage. But velocity ratio कैसे निकालेंगे आप? No, NA cannot have a unit. MA is load over force over force. MA is a unit. How will you find out? Okay, next after this, next question is what is the efficiency? Okay, the question is why is the efficiency of the pulley not 100%? No, it's not 100% because the effort applied is more than the load, right? The effort applied is more than the load. What is the energy gained by the load in 10 seconds? How much of energy will you gain? So the energy will be equal to mgh. So you know the mg part is how much? 400, and you are lifting it through a distance of 5. So the energy you are getting is 2000, how much? Joules. Okay, next question. How much power is the boy developing? Power is energy upon time. So what is the time? 10 seconds. So you're developing 200 watt. Next question. The boy has to apply an effort which is greater than the load he is lifting. What is the justification then in using this type of pulley? देखो ये questions कितने अच्छे रहते हैं. The boy is applying a force which is more than the load he is using. What is the justification then using this machine? It is giving him the comfort by changing the direction of the effort applied. A pulley can never be, it is easier. Not easier is not the right word. Changing the direction of effort. But question still remains, velocity ratio कैसे निकालेंगे? ये घर में सोचिए. Distance moved by effort over distance moved by load. So velocity ratio for a fixed pulley is always 1. It's a fixed pulley. A fixed pulley's velocity ratio is always 1. I just.
Efficiency is 5 by 6.
So its efficiency will be 5 by 6. 5 by 6 multiplied by 1, so it is 5 by 6. So 5 by 6 मतलब कितना हो गया आपका? 6 8 are 48, 220, 6 3 are 18, so 83.33%. And that's overall ठीक. Pulley will also. But did you understand why velocity ratio is 1? This didn't strike you. It should strike. In a fixed pulley, the velocity ratio is always 1 because the distance moved by the effort is equal to the distance moved by the load. इसीलिए पूछा. और ऐसे ही क्वेश्चंस आते हैं उनके. एक क्वेश्चन में कितने पार्ट है देखो. This is a typical ICSE question. In one question they have got 5 parts, I think. Yeah, see. The question comes like this: 1 A B C D E F G, 7 parts.
What's the number of questions?
And these children will compete with you after your grade 10